Hey, good morning, students. And today we'll be working on decision trees. Nowadays, we don't really use decision trees because it's overly simplified, and also it tends to have problem with overfitting. But decision trees are a core component of many very popular algorithms like random forest, gradient boosting, right? So, so I think it's very important that we understand decision trees. And once we understand decision trees, random forest gradient boosting will be much easier to understand. So let's start right now. So yeah, so decision trees is it we explain from the intuition perspective is fairly simple. You just try to traverse the part of the graph down, answering a different question, whether it's yes, no, etc. And most of the time is binary decisions in each of the part, and then eventually you reach the decision whether it should be which classes, right? So decision trees is not restricted to binary. It can be multi-class classification, right? But then you may ask, then there's nothing much to study about decision trees, right? We just need to construct a tree and let the tree make the decision for us, right? Just go left and right, right? But in in fact, the key point of decision trees is to make sure that we ask minimum amount of questions to reach the class that decision that we want, right? So how do we choose uh, uh, the variables to include on the tree? That is, which feature we should ask first, which feature we should ask last, right? In order for the tree to be not too tall or too high, right? So that we can minimize the amount of things we need to ask, right? And also, the question is, how do we choose the threshold? Because if height is less than that, go left. If height is greater than that, go to the right. But what is the threshold? And another thing that we have to ask is when to actually stop the tree. So the key idea is that we want to choose the feature that has the lowest impurities to split our tree. So, so what did that mean? Well, that means that we want to choose the feature that actually allow us to split two things between classes in the most isolated way possible, right? And one way we can measure impurity is using Gini index. And there's one more that is entropy, but in this class, we're going to use the Gini index. But entropy has a very similar idea. And the Gini index has this formula that is 1 minus the sum of pi, right? In which you want to take I equal to 1 until the number of classes, right? So that is the idea. That is, you want to sum the probability of each classes, square them, and you take 1 minus, right? So you can see that this is a very simple algorithm that can, a simple equation that can actually measure impurity. So let's say that C is the number of classes, and let's say we have two classes, 0 and 1, and the PI is the probability of each class. And let's say our X is, we have 4 samples with each of them only one feature. And let's say, this could be the width of some cancer, let's say. And we have 2, 3, 10, 19. And based on that feature, the Y is 0, 0, 1, 1, right? So if the width of your cancer is, let's say 2, then you probably have no cancer, for example. So so we have 2 nodes that are no cancer and 2 nodes with cancer, right? So in that case, if we want to, if you imagine that this is a circle with all these samples inside, and all this is the associated classes, then the question is, what is the Gini index of this node with all these 4 samples together? Well, we can calculate the P probability of having cancer is 2/4 because we'll have 2 of the 1, which is 0.25, same with no cancer. And then thus gene index is nothing but sum of the probabilities of each classes and y minus, which is then 0.5, right? In fact, 0.5 is the lowest possible number you can get from the gene index. You can try, but this is the worst impurity that we want, because we want in such a way that we can split the node in the most isolated way, and this is the most unclean way, right? Because you have equal amount of each classes. You want a node in which it can split in such a way that you have 1, 1, 1. Well, that would be the perfect one, right? If you have 1, 1, 1, then that would be 4/4. That would be 1, and 1 square, and then 1 minus 1 is 0, right? So that is the that's why I'm trying to say that 0.5 is the worst possible number you can have, right? So now let's say we have this node, right, with 4 samples. Now we want to know how to decide how to best split this node so we can get the lowest Gini index children, right? So let's say if I split this sample according to x less than 3, if I do x less than 3, then this number goes to the left, and these 3 numbers go to the right, right? In case, the left node has 2, and we have 0, and the right node has 3, 10, 19, and 0, 1, 1. So the weighted Gini index of the children are nothing but 1 divided times the left gene index plus 3 divided by 4 times the right gene index. And the left is nothing but 1 minus 1/1 square plus on the right side, because you have 2 of the class, so 1 divided by 3, and you have 2 classes, so 2 divided by 3, and you take 1 minus of this both of them. So finally, if you calculate, you get the Gini index of 0.33. So what is the point? The point is that you want to find the split that get the lowest number. So let's say if we want to try to take x minus less than 4, so then on the left children, we will have 2, 3, and the right children will have 10, 19. And when you calculate the Gini index, it's perfect because you get an impurity of 0. Why in that case? Because once you do that, you can notice that the left children have completely 0, and the right children is 1. And so this is a perfect split, right? Because what does it mean? It means that once you ask this question x less than 4, you can find the feature that is allowing us to classify into class 0 and 1 in a very clean fashion. And I don't think you need to ask any more questions, because this is a perfect question to ask, right? So you can see that if you want to construct a tree, this would be the question you would ask, and this is the threshold you would ask, right? So yeah, so in fact, Gini index is a perfect way for us to find how do we split the tree. Lastly, you may ask, how do we find the threshold, right? Why don't we just do x minus 3.5 or x less than 3? So the way to find the threshold is extremely simple. In the case that we have 2, 3, 10, 19, we just need to identify the critical value, and the critical value is nothing but the numbers in between. That is 2.5, 3 and 10, which is 6.5, and 10 and 19, which is 14.5. Choosing this critical value in between them is a very safe, as they give us a very balance, right? And a good balance and a good point to estimate the critical value. So that is the 3 values we will decide. And once we have points, we will try to iterate and try to find which one give us the lowest Gini index. All right, great. So let us write this code together. and see how it works. So recall that we have x equal to np.array. And we have 2, 3, and 10, and 19, right? And I have to run this np to make sure that I have numpy array. And we can print the shape, and that is, so we have 4 samples, each of them with one feature. And then, so now, what is the idea? Well, the idea is that, sorry, the idea is super simple. We have threshold 2.5, 6.5, and 14.5. The first threshold will bring us to having the left node as 2 and the right node as 3, 10, and 19, right? But in fact, this one will get us 0, 0, 1, and 1, right? In terms of y. And if we choose the second threshold, we'll get 2 and 3. And then this one will be 10, 19, and this one will be 0, 0, and 1, 1. And the third threshold will give us 2, 3, 10, and 19. And finally, this will give us 0, 0, 1, and this one will give us 1, right? So the idea is very simple. You just simply iterate across the threshold, and then you will find that the Gini index. So in fact, you don't really need to even know the threshold. You just simply put the first number on the left, and slowly put this number on the left, and put this number on the left, and that's it. And you just get 3 Gini index, and whichever Gini index is the best, you choose that threshold, right? So the idea is extremely simple. So now let us try to implement this right away. So find split x, y, and classes. So what do we have to do? So firstly, we're going to say n and m equal to x dot shape, right? And if n is less than equal to 1, we simply return, because I don't think we need to really return anything. Otherwise, what do we want to return? We want to return the feature x and the threshold, all right? Because this will give us which feature we should use it to split, and the threshold. In this case, we only have one feature. Well, that would be the feature 0, but the threshold is we really wonder which it is, right? So we need to return these 2 numbers. Okay, great. So now, definitely we will initialize this one and this threshold. I'm sorry, to be none and none. So that would be the first thing we need to do. And then now we need to do sample per class. Parent is equal to np.sum y equal to z for z in range any classes. All right. So this one, when you run it, what will it give you? It will give you 2, 2. That's it. So basically, it will give you that there are 0 of 2 classes and 1, 2 classes. So that is perfect for us. And the Gini index of the parents is nothing but, so let's say that we call this best Gini first, is nothing but 1 minus 0 sum of n divided by n samples, square them. And we just sum them for all the classes, right? So we just say n in sample per class parent, right? So this one, actually this one should be m, n, and then this one should be ni, right? All right. So I think that is very nice, and just okay, great. I make sure that I have n classes here. So this one is simply you taking each of the 2 divided by 4 square, and then 2 divided by 4 square, sum them, and then 1 minus, and then you will get the Gini index of the parent. All right. Now, what do you do? Well, you just loop each of the feature in range feature, which is m. So in this case, we only have one feature, right? And this loop will finish in one loop. But if you have 2 feature, it will try to loop more times. So what do we do? Firstly, we're gonna sort the sample. Sample sorted equal to sorted x feature, right? So we want to sort according to the feature of this one. So if this is 0, we want to sort that feature. The reason why we want to sort this feature is because we want to do this way. We want to make sure that is sorted, and then we just put left here, right? So that's why we have to sort. In this case, what this give us is nothing but just 2, 3, 10, 19, nothing else. And then what do we do is a sort index is equal to np.arcsort x feature, and then the y sorted equal to y sort index. All right. So this one will make sure that this is in this fashion, right? And this sort index is just to put it into this y. So that's not really anything. We just want to make sure everything is sorted nicely. Now the next thing is sample per class left is equal to 0 multiply n classes. So this would be 0, 0. And then sample per class right is equal to sample per class parent. All right, which is 2, 2. Okay. So what is this 2 things will do? Well, this one is assuming that everything is on the right side first, and nothing is on the left, and then I will slowly add this one of this into here, and calculate the gene index, and then I will add one more this into this, and then calculate the gene index, and then I will put this into here, and then calculate the gene index. Right. So that is basically the idea that we're doing right here. So for I in range 1 and n, so this one will give so give me just 1 second. So in fact I think this one I think there's some mistake here. It should be some number of samples and features, right? So why not we just call this m, and this is n, and this one should be m, and just let me make sure that everything is correct, and this one should be m and m, so that we don't confuse, because in our classes we use m to refer to samples, and this one should be n. Okay, so sorry for the fix, and then this one should be number of samples, right, which is m. All right. Give me just 1 second, and then to make sure that this is correct. Yep, this is that. Right. Okay, great. So then because m is 4, it will run from 1, 2, 3. That is moving this one to the left, and then this one to the left, and then this one to the left. 3 of them. All right. Now we say that C equal to Y sorted, I minus 1. So in that case, that would be the first 0, this one. The reason why we need to minus 1 is because we started at 1. So we want to take the 0. And then sample per class left, C is plus equal to 1. And then sample per class, right, C is minus equal to 1. And just make it very nicely. So basically, I'm putting this one, increasing this one or by 1 according to the class it is, right? So now this one will be 1, and this one will be 1, right? So after you do this, what do we have is basically 1 and 2, right? So this one will become 1 and 0, and this one will become 1 and 2. All right. And then what do we do is Gini left. Okay, I have an equation prepared, so I just copy to make sure that I don't make any mistake. So Gini left is that. So it's nothing but taking all the classes in here in range of all the classes. Similarly, we're gonna do for the right. All right, and watch this should be M. And M minus I is very nice. You just make sure that if there's only 1, you just take 4 minus 1. You will know how many samples left in here, and then that should give us a very nice Gini left. Finally, for the weighted Gini index, is nothing but that. All right. So I divided by M times the Gini left, and M minus I divided by M times Gini, right? So that is the weighted Gini of the children. And finally, if sample, we have to take care of this case, right? In case the value are the same, we do not split. Both have to end up on the same side of the split. So we have to make sure that that is taken care. So let's say that we have samples like 2 to 10, then we have to make sure that we handle that double 2. So if sample sorted I equal to sample sorted I minus 1, then we simply continue. That is we skip this threshold. We don't consider that this threshold is valid, and then we just move on to the next threshold. So to make sure that if this threshold is the best, this would be the threshold will always take that to 2, right? All right. Otherwise, if weighted Gini is less than the best Gini, the best Gini is equal to weighted Gini, and the feature index is equal to this feature. And the threshold is nothing sample sorted I minus sample sorted I minus 1. And then finally, everything divided by 2, right? So if really that one is the best, we just take the previous sample minus the current sample minus the previous sample divided by 2. We get the midpoint. That would be the threshold. All right. if I'm not wrong, that it is, right? And finally, let's see whether we have no problems in here. So once again, we have already prepared the X and Y. So let me just run this. And the way we do it is a feature threshold equal to find split. And the thing we need to have is Y, X, Y. And then we need to send the number of classes, and we just simply say that give me the set of Y and how long is that? That should give us. And let's hope that we got feature 0, right? Which is correct. And the threshold is 3.5. Okay. So there must be something wrong because the threshold cannot be 3.5 because if we take 3 and 10, it should be 6.5, right? So give me 1 second. There must be some slight mistake I made, and I will be back. Yep. Okay, I'm back, and I think I got confused here a little bit. It should be plus, right? Because we want to take the midway. So 3 plus 10 should be 13, and divided by 2 is 6.5. If we take 10 minus 3, it will be 7. 7 divided by 2 is 3.5. So this one should be plus, obviously. So if we clear all the outputs, restart, run all, that should give us 6.5. Great. So then we have this find split, and I hope that you understand this. Please feel free to add one more feature. And you can see that this function can also handle multiple features, and it will know the best split anyway. The question is, if you already use that feature, then what do you do? Well, you just use another feature, and finally, you will be able to construct the tree that is the shortest possible. At the same time, can find you the classes. All right. So let's implement this in the real world and see how do we actually do this. So to implement this, what I'm gonna do is I will first create a class called node. The node will contain the Gini index of that node, the number of samples, number of sample per class, the class of this node. It would just take the majority of that node, right? And the feature index, the threshold, left and right. So this class will contain, basically represent one of each node, what we would have. All right. And then, sorry. And then the next thing we will have is we'll define a class fit, in which this one will return node. All right. And so the first thing it will do is we will take m samples and n features from the xtrain.shape, and then we're going to calculate this n sample per class, like what we do. And the predicted class of that node is simply argmax of that one. In that case, we will know that this node belongs to which class, the majority class. And then what do we do is we create the node of the parent. All right. And the node of the parent is nothing but the Gini index and the predicted class, that is the tick, and number of samples per class. All right. So that one is the parent node. And then what do we do? Well, we just simply find the best split, taking this into the account. And once we do that, we have feature and threshold. What do we do? So firstly, we need to make sure that if the feature is not none, what do we do here? Give me 1 second. The index, we take the left indexes according to the left threshold, and then we assign all the features on of this left side as X and Y. And then I think you can already guess what I'm trying to do, right? But firstly, we also want to define for the right side, and we simply use this tutor so that it's a very nice feature, nice Python feature to allow us to simply select what should be on the right according to this threshold. And then we simply do this recursion. So we say that node.feature index is this feature and node.threshold is this threshold. And then we just simply do the left. So we do the left side again, and we do the right side again. And this fit method is nothing but this fit. So we do this recursion. Imagine that this is the parent, and then each of the parent have the left and right, and accordingly, this will construct the tree. So I really like to write this code simply because you will recall the recursion thing that you learned in the computer science class back then. All right, great. Give me 1 second. I think, okay, great. So this should give us a very nice fit function. All right. So let us punch this in. The next thing we want is the prediction function, and the prediction function is nothing but you take the sample, whatever sample you want to take. This is could be the X test, and this is tree. And if this is still less than the threshold, you keep going on the left. Otherwise, you go to tree, right? And if there's nothing else, you just give me the predicted class of that, right? So basically, you are reaching the leaf already, right? So this is the prediction function, and so finally, I have prepared the class, a lot of numbers of the X train and Y train and X test and Y test. So what do? Well, we just fit the tree and we'll get this tree. So what is this tree? This tree is a node, all right? And this tree, there's a node inside the node, all right? And the way we do is we simply take the whatever X here in the X test and predict. So we get the prediction, right? So this is what we predict for all this number 0, 0, 1, 1, and it seems like accuracy is perfect, right? So what do? Well, we can actually print the feature index, the threshold, the array of this and Y test. And of course, you can also run the classification report, and you will find that the accuracy is 1. All right. But as you can see, decision trees is prone to overfitting, and it's not recommended that you do a decision tree, because once the decision is made, it is prone to overfitting, right? Once you learn that, it may try to game the training set, and things will not be as desired. So that's why we have random forest, that is, have multiple trees to help design the majority, the best results based on different tree results. All right. So great. So I think decision tree that's it. Hope that you enjoyed this tutorial, and see you next time on Random Forest. Thank you. Bye bye.